Hello everyone, my name is Brittany Schwan, and I will be reviewing an article today entitled, How Can We Estimate the Death Toll from COVID-19? This article can be found in Chance Magazine of the American Statistical Association, and it was written by Deborah Boca and Howard Weiner. Deborah and Howard are trying to help us answer the question, how can we estimate the number of deaths caused by COVID-19? Determining causality has always been difficult, and COVID-19 has been especially challenging as someone has to make the assumption to COVID-19 contributing to someone's death. For example, we might have a 42-year-old with a known exposure to COVID-19 who ends up dying of respiratory failure. This is somebody who might obviously be labeled as someone with COVID-19. However, a much more common story is somebody who's older, maybe an 85-year-old, who has previously had issues using supplemental oxygen, and they slowly demise in the emergency room when things go bad, and their death is attributed to COVID-19. Unfortunately, we're relying on someone's assumption. So the goal of this paper is to provide an example of how to assess the deadliness of COVID-19 pandemic in a way that's unaffected by possibly idiosyncratic diagnosis. Fortunately, or rather unfortunately, we don't have to look far into the past to find an example that we can use for estimating the death of COVID-19. Specifically, we'll look at estimating the death toll from the plague. This image on the left is from the London Bills of Mortality, and it was instituted in the second half of the 16th century, and it was used to monitor burials in the city of London. And it kind of became this weekly mortality statistic. Of the 8,297 people buried this week, 7,165 of the deaths were attributed to the plague, and that's about 86% of the deaths. Now, if we graph the statistics that come from the London Bills of Mortality, we get the graph here. In the figure, the red line shows the total number of deaths, which was 97,306, and the blue line shows the deaths that were attributed to the plague, which was 68,596 deaths, so about 70% of the deaths. Usually, the fatality in London during the time period was about 15,000 deaths per year. So this suggests that more deaths were really plague-related than what was attributed to on the London Bills of Mortality, and that the true rate associated with plague deaths was about 85%. This type of analysis was called excess death analysis, and it's estimating the true effect of an epidemic by contrasting the death rate during the time of the epidemic with the death rates of the times during normality. The authors of this paper suggest using the same excess death analysis to apply it to the COVID-19 death toll. They suggest thinking of COVID-19 pandemic as an experimental treatment, and that we are trying to measure the causal effect of treatment on the lives of people in the US. So for this example, the treatment group would be the US population from February 1st to April 30th in 2020, so when the pandemic hit. And then the control group, they're suggesting using the US population from February 1st to April 30th in the years 2014 through 2018. The dependent variable in this situation would be the total number of people who died. And then they also suggest that because of the effects of COVID-19 vary by age, that we should stratify the sample by age to account for this. Table 2 in the article shows the number of US deaths per day from February 1st through April 30th. Because of leap years in 2016 and 2020, the number for each year was not precisely comparable, so the authors adjusted for this by calculating a daily death count as shown in this table. Then what the authors did was they calculated the mean for each of the different age stratas that we have used for our stratification. Next, the authors display table 3. In this table, we have the age stratas, Actual is the number of actual deaths in 2020. The fit from model column comes from the model-based estimations based off the daily deaths in 2014 through 2018, so that mean column in the previous table. And then the residuals are the excess number of deaths in 2020. The residuals estimate the causal effect of the treatment, so being in year 2020, relative to the control, being in years 2014 through 2018. When we're looking at the residual column for ages 0 through age 44, we're not really noticing that much of a change. In fact, a lot of times the residual ends up being negative, which means that there's actually less deaths in 2020 than what we would be anticipating for those age groups. Another area of note is for the age range 45 through 54 years of age, where we have a large negative residual of negative 47. It's really important to note that this model accounts for all reasons that the treatment year, so 2020, differs from the control years. One of the reasons that COVID-19 has changed things for us is the fact that there's been stay-at-home orders introduced at the end of March. The stay-at-home orders reduce the number of vehicles on the road, meaning that there's less motor vehicle fatalities. In typical years, the age group that's most affected by these motor vehicle fatalities is the age group that we're mentioning, the age 45 through 55 years. So that could be another reason why the residual is that large negative number. Unfortunately, what we're seeing is a large excess in the number of deaths for individuals who are 65 years of age and older. You can see that for excess deaths of these individuals, we're ranging from 100 to about 200. This is in line with what we've seen in COVID-19 and how it disproportionately affects older individuals. Looking at the sum of daily deaths, we see that there is a residual of 443, meaning that the excess number of daily deaths in 2020 is larger than it was in previous years, and we're attributing this to COVID-19. Although the authors brought up a lot of really interesting points, there's some additional challenges remaining. Specifically, the data that we used only came from February 2020 to April 2020, and now that we're into December, we have a lot more data available that we could use to create better models. And another thing to note is at the beginning of the pandemic, there were very few COVID-19 deaths reported. So the model presents kind of an excess of deaths in April averaged over a 3-month period to kind of make up for that. The model also calculates the difference in deaths. A pro of this means that the estimates calculated are not dependent on anyone's classification of cause. It avoids possible idiosyncrasies of diagnoses. But a con means that those does not account for other changes that exist in 2020 that may affect fatalities. We saw this in the motor vehicle fatalities being reduced for that age group 45 through 54. The model also works for linear growth, but what we've been seeing is that the pandemic displays exponential growth. So using the average over time kind of produces a distorted representation and might not be applicable at the moment. I hope you found this article discussion interesting and informative. I think that this topic of trying to understand fatalities and the causes of those fatalities is an important thing not only for this global pandemic, as we're trying to understand the effects and the aftermath of COVID-19, but for future pandemics as well. So if you have any additional, discussions or anything, go ahead and leave a discussion comment and I will be sure to respond. Thank you for your time.